Imagine standing on a cliff at the edge of the world, staring into a darkness that hasn't seen a human footprint in over 50 years. For half a century, humanity has remained in the shallow waters of low Earth orbit, sheltered by the invisible magnetic cocoon of our planet. But on April 1st, 2026, the silence was broken as the Space Launch System ignited, carrying 4 pioneers, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, into the lethal depths of space. They didn't just break a distance record by traveling 406,000 kilometers from home. They stepped into a gauntlet of survival that the human body was never evolved to endure. NASA scientists call this gauntlet the Ridge Paradigm, a classification of 5 deadly hazards: radiation, isolation, distance, gravity, and environment. As the Orion spacecraft pushes beyond the magnetosphere, the homeostatic balance of the human body begins to shatter. Almost instantly, the first and most silent assassin is radiation. Unlike the relatively safe environment of the International Space Station, where Earth's magnetic field filters out the most dangerous particles, the Artemis II crew is fully exposed to a 3-headed monster. First, they must pierce the Van Allen radiation belts, 2 massive rings of high-energy protons and electrons trapped by Earth's magnetic field. Though they move through these belts at ballistic speeds to minimize exposure, the intensity is a chilling reminder of the world they are leaving behind. But the belts are only the beginning. Once in open space, the crew faces solar particle events, sudden, violent eruptions from the sun that can release more energy than billions of hydrogen bombs. A crew caught unprotected during such an event could face acute radiation syndrome, suffering from nausea, central nervous system collapse, and even death within hours. Yet there is a third threat, even more relentless: galactic cosmic rays. These are heavy ions traveling at near-light speed, born from the remnants of ancient supernovae from beyond our solar system. They are so energetic that they can pass through the aluminum hull of the spacecraft as if it were paper, creating a secondary shower of lethal neutrons the moment they strike the walls. NASA has set a career limit of 600 millisieverts of radiation to protect its astronauts. But a single long-duration mission to Mars could shatter that limit, pushing exposure up to 1,200 millisieverts. On this 10-day journey, the Artemis II crew is the ultimate experiment in human resilience. How do you survive a storm you cannot see, in a place where there is nowhere to hide? The Orion spacecraft is not just a capsule, it is a masterpiece of radiological engineering designed to outsmart the sun. Instead of relying on heavy lead shielding, which would be far too costly to launch, Orion uses a concept called repurposed mass. When a solar particle event is detected by deep space observatories like DSCOVR, the crew has only 15 to 60 minutes to act. They retreat to the most shielded section of the capsule, the aft bay, near the heat shield. There, they take water tanks, food bags, and toolkits and stack them around themselves to create a temporary storm shelter. This method is often called a palm pillow castle in popular media, creates a hydrogen-rich barrier that is remarkably effective at slowing down solar protons. The effectiveness of this protection was proven during the uncrewed Artemis I mission. Through the MER experiment, the most complex radiation study ever sent into deep space. 2 anthropomorphic phantoms, Helga and Zohar, were placed in the crew seats. These were not mere plastic mannequins. They were constructed from epoxy resins that precisely mimicked the radiological absorption properties of human female tissue, including bone marrow, lungs, and the uterus. More than 12,000 sensors tracked the radiation as the phantoms passed through the Van Allen belts. The findings, published in the journal Nature in 2024, were revolutionary. They revealed that the storm shelter reduced the radiation dose by a factor of 4 compared to the unprotected areas of the capsule. Zohar, however, carried a secret weapon, the Astrorad vest. This high-density polymer vest, weighing approximately 27 kilograms, was specifically engineered to protect stem cell-rich organs, particularly the bone marrow. The data showed that astronauts wearing this vest could survive extreme solar events and potentially extend their spaceflight careers by up to 190 days. But while the shield holds against solar protons, it remains nearly transparent to galactic cosmic rays. The only moment the crew found relief from these intergalactic bullets was when they passed behind the moon, using its massive silhouette as a natural shield, dropping their exposure by 30%. And to truly understand the cellular damage these rays cause, NASA didn't just send humans, they sent avatars. Inside the Orion capsule, tucked away in devices no larger than a USB drive, a revolution in space medicine is quietly unfolding, the Avatar Project. These are organ-on-a-chip technologies containing live bone marrow cells derived directly from the crew's own blood. Since bone marrow is the factory for our blood and immune cells, it is among the first systems to fail under sustained radiation. By monitoring these biological avatars in real time, scientists can observe exactly how microgravity and cosmic rays accelerate aging and disease, opening the door to personalized protective treatments in the future. But radiation is only half the battle. The very absence of gravity is dismantling the crew's bodies from the inside out. In a weightless environment, the body undergoes a profound and alarming transformation. Without the mechanical stress of gravity, the bones receive a signal that they are no longer needed. Osteoblasts, the cells responsible for building bone, go dormant. Meanwhile, osteoclasts, the cells that break bone down, accelerate their work. Astronauts can lose between 1 and 1.5% of their bone mineral density every single month. That is equivalent to what a post-menopausal woman loses over an entire year on Earth. And this calcium doesn't simply vanish, it floods into the bloodstream, dramatically increasing the risk of kidney stones. Even with 2 hours of intense resistance exercise every day on the ARED device, skeletal decay can only be slowed, never fully stopped. Perhaps even more unsettling is SANS, Spaceflight-Associated Neuroocular Syndrome. Affecting nearly 70% of astronauts, this condition develops as bodily fluids shift toward the head in microgravity. Intracranial pressure rises, physically flattening the back of the eyeball and compressing the optic nerve. This can cause permanent visual changes, pushing an astronaut's eyesight toward irreversible farsightedness. Recent studies from the Australia Space Institute have revealed that even biological sex plays a role. Female astronauts exhibit distinctly different fluid shift patterns compared to their male counterparts. Meanwhile, the hostile environment of the capsule causes the crew's own microbiome to mutate. The combined stress of radiation and confinement can make common bacteria more virulent and cause dormant viruses, such as shingles and Epstein-Barr, to reactivate within their cells. These pathogens wait, patient and silent, for the immune system to weaken just enough to strike. As the crew reaches the far side of the moon, they encounter the third and fourth hazards of the ridge paradigm, distance and isolation. For nearly 3 hours, they pass behind the lunar mass. Every radio signal with Earth is severed. In that absolute silence, they become the most isolated human beings in existence. If a medical emergency were to occur, a cardiac arrest, a traumatic injury, there is no evacuation route and no real-time guidance from surgeons in Houston. This is precisely why the Artemis II crew is trained in autonomous medical operations. They use portable ultrasound devices, like Ultrasound II, to diagnose their own internal conditions, supported by AI-assisted diagnostic systems. They are not merely pilots. They are their own physicians, preparing for the day when astronauts on Mars will face a 20-minute communication delay with Earth. The psychological toll of this ice environment, isolated, confined, and extreme, is measured in real time by the Archer project. Wearable actigraphy sensors on the astronauts' wrists track every fluctuation in sleep quality, stress levels, and team cohesion. They must navigate the third quarter phenomenon, a well-documented period in long-duration missions where routine gives way to monotony and creeping depression before the tension of the final return sets in. And every breath they take is a delicate chemical balance. Rising CO2 levels within the small cabin can blunt cognitive function, making the difference between a successful maneuver and a fatal mistake. The final test came on April 10th, 2026. As Orion slammed into Earth's atmosphere at 11 kilometers per second, Mach 33. The air in front of the capsule compressed into a superheated plasma, reaching temperatures of 5,000 degrees Fahrenheit, hot enough to melt any metal known to man. The only barrier between 4 human lives and total incineration was the heat shield, a composite titanium skeleton covered in precisely molded Avcoat blocks. Following an anomaly discovered during Artemis I, where trapped gases caused sections of the shield material to crack, the Artemis II crew executed a skip entry maneuver to distribute the thermal load across a wider arc. As they splashed down in the Pacific Ocean, they carried back far more than scientific data. They proved that while the ridge paradigm represents a deadly and unrelenting gauntlet, the right combination of bioengineering, intelligent shielding, and human courage can transform the most hostile environment in the known universe into a frontier we can finally call home.